Hey guys, welcome to Concept and Coding, and this is Shreyansh, and today we are going to do the first topic of Spring Boot, that is Introduction to Spring Boot, and I will cover this thing, what problem it solves and its features and advantages. So let's start without wasting any time. So why Spring Boot exists today? What problem it solves, right? How it is different from Spring Framework? There are a lot of questions about it. So to total clarify about it, like the complete picture, we have to go little bit back when servlets were popular. So back in 2015 and 2016, I worked a lot on servlet and I know how hard it was to manage the application. And currently we are working on Spring Boot and we know that how easy it is compared to servlet. So I will not tell you about in depth about servlet, but at least I will tell you what problem was exist in the servlet, what problem it solves. Okay, so let's go. So that's what I mentioned. Before we talk about Spring or Spring Boot, first we need to understand about servlet and servlet container. So these are the foundation for building web application. Back in 2013, 14, 15, these servlets are very popular. And these are, you can say that the foundation for the web application. Spring and Spring Boot internally uses the same concept, right? So servlets actually build the foundation. So what is servlet? Servlet is a Java class which handles client request, processes it and returns the response. So consider it as a class where you have defined your API. Input request comes in. This is known as servlet. This API got invoked. It will do some processing and return the response. So this actually, which handles the request, processes it and returns send the response back, is known as servlet. And what is servlet container? Servlet containers are the one which manages the servlets. So there can be so many servlets. So servlet containers are the one which manage these servlets. Okay, so I will come to this diagram, but let me first tell you in a very easy manner how we used to write a web application. Very simple. Only one, you can say that one class I will tell you. So this is how servlet used to look like. Okay, so I have defined my API here. So here @web servlet / demo servlet, right? Demo servlet 1. So this is, you can say that my API, and I extended with HTTP servlet. So one servlet can have only one do get, do put, do post, do delete, right? These are the methods which we have to override and provide the implementation. So here if you see that this is the servlet, and in this method any get request which comes, it will come to this. So it will comes to this. I am doing processing and ultimately will send the response if required. So currently I am void, no response. So any response will go. So HTTP response will go in this response. I can set it here. Okay, so this is known as servlet. So this is, I make another servlet because we can have more than one servlet. So that's why I created another servlet and give them the name demo servlet 2. Okay, so in this servlet also I can have do get, do put, do post, do delete, right? And do something and return if required. So I can have multiple servlets. So there is something called web.xml, and this is the culprit actually, which makes everything too complex. So what in the web.xml, there are so many things we used to do, filtering and all, right? But let's keep aside the one thing which we have to do is the servlet mapping. So what servlet mapping is that, so this is one servlet, demo servlet 1, right? So this is the servlet name, demo servlet 1. What all URL this will handle. Okay, what all URL this will handle. So let's say slash demo servlet 1. This if customer hit this URL, let's say demo servlet 1. Okay, so it will comes to this servlet. So this servlet will handle. So that's what its mapping is. If user invoke this API slash demo servlet 1 slash first endpoint, some endpoint, which servlet will handle? There are multiple servlets, servlet 1, servlet 2, servlet 3, servlet 100. So if customer hit this API, which servlet will handle? So I have mapped it to servlet 1, this servlet. So that API will come to here, this servlet 1, and after this it will go inside a particular method. If user has hit the get HTTP request get, so it will go inside do get and check the request info. Okay, first endpoint slash demo servlet 1 and user hit first endpoint. So okay, this else if will get executed. Okay, and if user hit this API, so in the servlet mapping web.xml, it has been mapped to which servlet? Servlet demo servlet 1. So it will go to the demo servlet 1, and let's say it is again a get call. So it will go to the do get, and then it will check all the if condition. Okay, this else if condition got matched slash second endpoint. So this processing will start. So you got it. If the put API got invoked, put slash demo servlet 1. So what would get invoked? Okay, demo servlet 1 is the API which is mapped to this API, this servlet. Okay, this servlet will invoke. This is the put, so it will go to do put, and then it will see, okay, this is the path and do the processing. So similarly, another mapping I have done is for my second servlet. So this is how servlet used to work. Now let's come to this diagram. So when input request comes in, it first has to goes to the Tomcat. This is the server which is also known as actually your servlet container, right? This is not service container, my bad, it's servlet container. So Tomcat used to know also known as servlet container. Okay, so we have to deploy our application here in the Tomcat servlet container. So our application has all this servlet 2 and all this. We will convert it to var and we will deploy it here in the Tomcat. Now what this servlet container will do, I told you that servlet containers are the one which manages the servlet. So what it will do is at the first, it will use the web.xml and see that, hey, user has invoked demo servlet 1 slash first endpoint. So now this servlet container will use this web.xml, this mappings, and identify which servlet has to be invoked. So in web.xml, it will check that, okay, demo servlet 1 first endpoint. Yeah, demo servlet 1 first endpoint, this one. Which servlet gonna be handled? This is the name, servlet name, demo servlet 1. Okay, so this is the name, demo servlet 1. Which class? Demo servlet. So I have kept the name and class name same. So this is the name, you can give any name. So with this name, it will find out the mapping class. So this class will get invoked, and this class is the servlet class. So it now know which servlet has to invoke, and then ultimately it calls the servlet, right? So it will call this demo servlet 1, right? That particular method, because it knows that it's a get call, right? So it will invoke its do get method, and now this servlet should be able to handle it. Okay, so this piece of code would be executing it and it will send the response back. So you got the how servlet used to work. Now there are certain problems in it which Spring framework solves. Right? Spring frameworks is, you can say that, is a family which has lot of features. Right? And you can say that even Spring Boot comes under this Spring framework only. Okay. But I would say that before Spring Boot comes, there is something called that Spring MVC. This comes before even Spring Boot. Okay, so we will come to Spring Boot. So to solve the issues of the servlet, I will tell you the issues. Spring MVC comes into the picture. So what all problems it solves? So Spring framework solves challenges which exist with servlets. What? First, removal of web.xml. This web.xml becomes too big. So because see, when you work on a production level application where it handles millions and billions of requests, this one servlet, two servlet, there can be hundred of servlets, and to have the mappings of those hundreds of servlet, it becomes too big, right? Also, this web.xml holds lot of information like filtering. Any request comes, it has to go through filter. What sequence of filtering it has to go, that also maintains over here. So this web.xml contains lot of information, and it's become very difficult to manage and understand it. So Spring framework introduced annotation based configuration. So removal of web.xml completely makes developer life lot easy, because now developer can work through annotations. Okay. So the second advantage of Spring framework is inversion of control. Very important. IOC. So what IOC definition is? IOC is more flexible way to manage object dependencies and its life cycle through dependency injection. So sometimes you say that, hey, dependency injection, and sometimes some people say IOC. Both are same. So generally you can say dependency injection is an implementation of IOC. Okay. So sometimes somebody calls IOC, sometimes somebody say dependency injection, but they both are same. Okay. So what is inversion of control? I'll tell you here. Let's see this example, then we'll come back to more advantages. Okay. So here if you see that, consider this example. Simple Java class. Okay. In this simple Java class, I have created a payment class, and this payment class is depend on this user. So I am creating an object of this user. There is a simple method get sender details ID. So what I am doing is I am using this object sender, calling its method get user detail and passing the ID. So what it will do is it will invoke this user class, this method, pass the ID, and it will fetch certain data of this ID and maybe return it or do something. Okay. So what is the problem you see? I see there is one major problem is very tight coupling. So there is a very tight coupling between payment and user class. You can ask me, right? Hey Shash, what do you mean by tight coupling here? So see, this is, I can tell you what I mean by tight coupling. Suppose I want to write unit test cases for the payment get sender details method. You already know that unit test cases means only if, let's say, if I am writing a unit test cases for this payment class, right? So I should have the capability to test this method, only this method. If this method is invoking some outside different class method, I should be able to mock it. Mock it in the sense, okay, sender dot, if whenever this is called, let's say I should always get this value. So I mocked this. That's what unit testing is, right? You should be able to mock the data which you are not testing. Okay. So as in the mock testing of this class and this method, I should not test this. So that's why I should be able to mock it. But will you be able to mock if you are creating a new object here? If you are creating a new object here, it will definitely call this for sure. So how you will mock it? There is no way, right? So definitely writing a unit test cases would gonna be very difficult. So how the inversion of control or dependency injection solve it? So in Spring framework, again don't worry about this annotations. I will explain the annotation in the upcoming session. But this component, auto wired, what is the usage of this component? Just keep aside first. But just understand the concept, right? So with the dependency injection, what problem we solved is, so now here we have used certain annotation which tells the Spring that, hey, you manage it. Okay, so here if you see that user, I have given @ component, and now this I handle it to the Spring. Hey, you manage this bean. Okay, you manage this class. Similarly, payment also I have created @ component, and this class is also now get managed by Spring. And here I have put @ AutoWired. So AutoWired tells the Spring to resolve and add this object dependency whenever this class get initiated. Okay, so now whenever this class get initiated, what Spring will say that, okay, @ AutoWired is there, means I need to create an object of it. Okay, so it will resolve it. Spring will resolve the dependency. It will create object. We are not creating object here like this. Okay, so what advantage we get here? The advantage is, let's say that first unit test cases. Unit test cases, I can mock it. I can tell Spring, hey, create a mock data for it. Mock it. Now during runtime, Spring will create a mock object of it. And using that mock object, I can say that, hey, whenever that mock user object dot get something has been invoked, do this. Okay. So what happened is that now we have the control. Okay. So here I haven't hard coded it like new user, which always create a new user. Now this is getting managed by Spring, and this process is known as dependency injection. Unit testing is much harder in Servlet, and I already told you how it become easy in the Spring through dependency injection. We have already seen the process. Difficult to manage REST API. As you already see that each servlet can have only one get method, one put method, one post method, right? One particular servlet. But let's say there can be, for this servlet, let's say there could be 10 APIs which has to handle. So generally this is how we used to do. If, else if. Okay. So in this path, which is handled by this servlet, whenever this path comes, do this. Whenever this path comes for the get, do this. Whenever for get this path comes, do this. So it's not very, you can say that flexible way to handle the input request which is coming, right? So path mapping makes code little difficult to understand. That's what I used to feel, right? So Spring MVC provide an organized approach to handle the request, and it's easy to build RESTful API. I'll tell you, like, very simple. We are also using it, right? Very easy way. So here if you see, I have also taken an example, this one. So we have a like @get mapping this path. Now you can have another another get mapping. Let's say @payment some certain my endpoint, certain endpoint, let's say 1, right? So you and its method public string, public string, some, let's say, method. Now do something. So in one class, we don't have to have like all the get APIs, if else, if else, if else. You can have proper, if there are 10 get APIs, you can have 10 mappings properly. So it's very easy to understand. It's you can say that a more organized way of handling the request. Okay, so it's easy to build RESTful APIs. So there are many more advantages of a Spring framework, and the Spring framework brings lot of other advantage. I have already told you that integration, lot of integrations are present. Okay, developer can choose different combination of technologies and framework which best fits their requirement. For example, for unit testing, you can choose JUnit, Mockito. Integration is available in Spring. You can start using it. Let's say for data, you can use Hibernate, JDBC, JPA. Lot of integration available. If you want Hibernate based upon your specific need, go ahead, use it. If you want JDBC, go ahead, use it. Similarly, for asynchronous programming, caching, messaging, security, all integrations present. This will take your picture, clear your picture completely. Okay, about this Spring framework. So request comes in. Again, like a same, here we have something called servlet container. So Tomcat is the servlet container. We have to deploy our application here. Remember the word I am saying. We have to deploy. Right? So whatever the application we have to create a var, deploy it here in the servlet container Tomcat. Okay. Why I am focusing it more? Because it's an advantage of a Spring Boot. I'll come to that. So in the Spring framework, or you can say that in the Spring MVC earlier, when request comes in, it goes to the servlet container. In the servlet container, which is Tomcat, we have deployed our application. Then the request goes to dispatcher servlet. It is also known as the first controller. Also known as first controller. Dispatcher servlet. Okay. So in Spring, these classes, these classes, right, where we have exposed the APIs, right, this is known as controller, right? So we can have so many controller classes, right? Let's say I have this payment controller, right? I have this payment controller class. I have put the annotation controller to tell the Spring that this is the controller class. So any API will come, you will find certain mapping here. So similarly, I can have so many controller class. Let's say that class order controller. I will also have annotation @controller here. Sales controller, something. So many controller class there. So which controller class to invoke for this API? So let's say that the request comes slash demo slash endpoint 1. This API comes. Now which controller will handle it? In the servlet, this is going to do that stuff. Servlet container. But in Spring, no. Spring, there is something called dispatcher servlet. So this servlet container, pass it to dispatcher servlet, all the endpoints. Now this dispatcher servlet, which is also known as first controller, will decide which ultimately controller I have to pass this require. And how it will do? So first it will choose the controller and it uses handler mapping. Okay. So here we are doing request mapping. Here if you see, these are the annotation. I told you we are not doing web.xml. We are not creating web.xml. In Spring framework, annotations we are using it. So you can just see that internally it might be doing certain XML configuration and all. But for us, it's a simple annotation that we have mapped this class. We have mapped this payment controller class to handle this request mapping payment API. Okay. So like this mapping we have done. So first dispatcher servlet uses the handler mapping to know which controller to invoke. Now it knows that, okay, for example, payment API. Now let's say instead of this demo, it is /payment API. Now based on this handler mapping, it knows that, okay, it has to invoke this controller, payment controller. Okay, now it has to create an instance, right? Because because here in the Spring, you won't find anywhere equals to new. So dispatcher servlet is now going to create an instance of what? Create an instance of your controller class, payment controller. So now it will create an instance of your payment controller, and it will use, or you can say that the leverage IOC, inversion of control now. Now what it will do is that, okay, I need to create an instance of payment controller, but for that I have to also resolve the dependencies if there are any. So it will see that, okay, IOC. Now it will goes to the IOC. IOC uses dependency injection, and with that it will say that, okay, @autowired means this payment controller is dependent on this object. I have to resolve it. So now IOC will create an object for this and inject it, right? So it will on the fly, it will now create an object of it and populate it with the object. Okay, so now the instance is created for this, and all the dependencies are resolved for this, where this class depend on us. All the auto wires are resolved by whom? By IOC, right? All the dependencies are injected. Now what it will do is dispatcher will invoke the controller method, particular method. So now that particular method, let's say the API was endpoint is, let's say, /payment API /payment. This is the request. So it will say that, okay, /payment, it will invoke this particular get mapping. Okay. So here if you see that these mappings helping the dispatcher servlet to determine which controller and which method to invoke. Which controller and which method to invoke. Okay. So is it clear? Like when I'm saying handler mapping, what does it mean? These mappings, request mapping, get mapping, these are ultimately helping the dispatcher servlet to determine which controller to call, and in this controller which method to invoke. Based upon this API which is coming, it will do this mappings and find out the controller and method. So ultimately invoke the controller method. So this will now process it and then ultimately return it, and it goes. So Spring framework is clear, right? Where the IOC comes into the picture actually, right? Okay. So till now you clear that from the journey from servlet to Spring framework, which is Spring MVC, you know the advantage. Now, what's the need of a Spring Boot now? What's the use of a Spring Boot? But before Spring Boot, let's see the one example of Spring MVC. So that will clarify when we will see the advantage of a Spring Boot. So this is a very, very simple Spring MVC application. You can say that. Okay. I have created a controller class, one controller class like payment controller. Again, ignore the annotations. We will see the annotation in depth. But for now, just remember this is one of the controller, one of the controller class, where kind of a similar to servlet, where any request comes in, processes it and return it. Okay. And these are the mapping. In servlet, we were doing a mapping in web.xml. In Spring MVC, these are the annotations we are using, and it mapping. Whenever any API comes in, So these mappings helps which controller should handle it and what method, and dispatcher servlet is going to use it. So this class is created. This is something called pom.xml where we have written the dependencies. So this is first dependency. Let's say we are creating a web application, Spring MVC. So we have created its version. Then you want servlet. You have created its version, added the dependency. Let's say you want unit test cases, JUnit. You have added its dependency with the version. So for simpler perceptive, I have written 3 dependencies. You can write into the pom.xml. This is Maven, right? So I have written 3 dependencies. The another class is app config. So this class, in this class, generally in the Spring MVC, we have this annotation important, where what this tells is that it loads lot of dependencies which Spring MVC is required, right? So it loads all of it. Then another annotation you have is @component scan. So we provide a package. So what is this? Only within this package, you are telling that, hey Spring, only within this package and below, you go and manage whatever the controllers or whatever the controllers I am creating it, right? Controllers, beans and all. So we are telling Spring to do a scanning, whatever, because Spring has to search, right, the controller and everything. So we have to give it a path from where it has to start searching for the component scanning. So we can provide it here. So that's where it's known as configuration classes, because it load configuration for Spring MVCs which is required to work, and also component scan, we define it here. And I told you that dispatcher servlet is used in Spring MVC, and this dispatcher servlet is the first controller. All the requests from servlet controller comes to it, and it performed all this stuff. Select, choose the controller, create an instance. So that's why there is one called dispatcher servlet class we have to create like this in Spring MVC. We have to extend this dispatcher servlet, this one, and we have to provide this 3 methods. We have to override these 3 methods. Provide what is the config class. We can provide it that this is our config, because this class name can be anything, right? So we have to give like what is the config class. So any dependency it required, it can load it. Enable MVC, right? This is an annotation. So this annotation load lot of Spring MVC kind of libraries internally. Then servlet mapping. So we have told that any request coming with this slash itself, you have to handle it, right? So those also we have mentioned in this dispatcher servlet. What all requests it has to handle. So this means all. Okay. So this, if you see that even a basic application I am writing, I have to have one controller, this POM, this config, and this dispatcher servlet. And you already know what is the dispatcher servlet does, controller and IOC and all. So this Spring framework is clear. Now you can tell me, hey Shreyansh, why Spring Boot is required? What problem Spring Boot solve? Why it exists today? Spring Boot solve challenges which exist with Spring MVC. 3 big things. First, dependency management. Here if you see that in the Spring pom.xml, Spring MVC, if you focus a little bit, you are adding a dependency whatever you required, and you also have to provide the version. Now let's say that in future you have to upgrade the version of JUnits from let's say 4.13.2 to let's say 5.1.2 something. But will this version work with this version also? It might not, because you know that the dependencies should be compatible with each other. So this is one problem with the Spring dependency management. So no need for adding different dependencies separately, and also their compatible version heading. Springs keep it easy. So Spring Boot keep it easy. You have to just give like this: starter web and starter test. So this web already internally it will load whatever dependency it required to create a web application. This will load whatever the dependency it required for testing. So it will automatically add the dependency for you. And here also, if you see, you are not defining any versions also. So you don't have to worry. It will automatically load those versions which are compatible with each other. And internally it will load all the dependencies which might require for creating a web application. Here you might require 15-20 dependencies. I have written only 3, but it might require 15-20, but here you might only need 2. Internally it will load. All in here you need is that this parent. That's all. What Spring Boot version you are using? 3 version. That's all. You have to define the Spring version here, starter parent version. Rest all this thing you don't have to define the version itself. Internally it will keep loading, keep adding the version. It is now a Spring Boot heading. So dependency management is the first advantage of Spring Boot over Spring MVC. Okay, so understand this, that this is your Spring MVC. This is your Spring Boot. So all the benefits of Spring MVC is also present into Spring Boot plus additional something. So dependency management is same thing. It is doing the same thing. Spring Boot is doing the same thing as Spring MVC, but now it's a little bit abstracted to us. Second advantage is auto configuration. Here if you see that this dispatcher servlet, this is kind of a configuration, right? This class is kind of a configuration. This class is also a configuration. Web MNCs, app config, right? These are a lot of configuration class. So that's why another advantage of Spring Boot is auto configuration. No need for separately configuring dispatcher servlet, app config. You don't need to define component scan, web and enable web MVC. Spring Boot internally add by default values for it. So Spring Boot internally will add by default values of @component scan. So wherever your application start application exists, main method, from that package onwards it will start. So what it does is there was a term called, if I remember correctly, there was a term called opinionated. Just double check once. I think that's why we call that Spring Boot has opinionated nature. Means it will give opinion. So opinion means it choose by default. Hey, component scan, I am choosing the package as from wherever your application main method starts. That package I will choose. So if most of the time you can go ahead with this Spring Boot opinion. Okay, so that's why you don't have to write this. But let's say that if you are not agree with Spring Boot opinion or by default, you can anyway add this your own also. I will tell you. You can add it. But that's why it is known as auto configuration, means no need for separately configuring all this dispatcher servlet, app config, component scan. Spring Boot add internally by default. But if you want, you can, in this Spring Boot class, you can add component scan if you want to change the default values. Right? We will see that @component scan, what does it mean and all. Don't worry about this, but understand what is mean by auto configuration. And there is a term called, I think, opinionated. That's the same thing. Spring Boot gives the opinion that I am using this. So if you are agree with its opinion, you don't need this configuration, or it's auto configured. If you deviate from its opinion, you can write component scan and give your package from where to start. So only one class you required here in Spring Boot is this Spring Boot, this annotation, Spring Boot application annotation. So this annotation itself internally has @enable web MVC @component scan dispatcher servlet. All the configuration, auto configuration are, you can say that, hidden inside this one annotation itself. And this is your main method, the start of the application. Okay, so second advantage is clear, auto configuration. There is now, you don't need to create this class, you don't need to create this class, you don't need to do @component scan. Everything is taken care by Spring Boot itself. So now it's very clean class one. And the third very big advantage is embedded server. So if you remember, I was focusing on the term that we have to deploy, or we have to first create a var of our application and deploy that into the Tomcat, which is a servlet container. Okay, in both servlet and Spring MVC. But in Spring Boot, server is already embedded. You don't have to generate a var. You don't have to take a var and deploy it to a Tomcat or a servlet container. Server is already embedded inside it. It automatically does it for us. We don't have to do it. Right? Servlet container is already embedded. We don't have to do all this stuff. Just run the application. I will tell you how. So what is Spring Boot in simple term? It provides a quick way to create a production ready application. It is based on Spring framework only, Spring MVC. It supports convention over configuration. I already told you that auto configuration part, right? It uses default values for configuration, and if developer don't want to go with convention, the way something is done, they can override it. Convention means the way something is done, default values. If you don't agree with the default values, you can always override it. That is convention over configuration means. So it supports convention over configuration. It also helps you run an application as quick as possible. Right? So now this is very simple. Here if you see that pom.xml is very simple. Here parent is there where with the version, but now it's dependency. Here if you see that only 2 dependency, you don't have to add more. You don't have to add version also. So you don't have to worry about dependency management. There is nothing, no configuration. You created one controller class. I have defined controller class. I have defined the mapping, which API one get call for sampling. And this is the start application. I told you why it is required. All the auto configuration here hidden inside it now. Now when you start this application, this method, and if you on the Chrome, if you just call this, if the client is invoking this /my API/first API. Spring Boot is nothing but a Spring MVC, right? The same. Dispatcher servlet is hidden to us, but internally dispatcher servlet will use this mapping. It will identify, okay, my API, which controller? Okay, my API is mapped to this, my controller. Okay, first API, which method? This get method will get invoked, and it will print this hello from concept and coding. So dispatcher servlet will create an object of it, and it will pass it to IOC if there is any to resolve any dependency. If there @autowire, nothing is there, so no need of IOC. It just simply create an object of this and invoke this. Okay, so let me show you. Here this is the Spring Boot. Here if you see, I am just simply running. Run. Here if you see that Tomcat is started. So I don't have to create var. I don't have to deploy. Automatically server is started on this port. Now we can just simply go, and in the Chrome we can add this API localhost. This is the port where it is started, and this is the API I am hitting. So this is the API I have written, controller my API, and this is the endpoint first API. If I press enter, hello from concept and coding, hello from concept and coding. Don't worry about this setup of this project that we will see in the second part, second session. But focus on the points like why Spring Boot needed at the first place. That was the big. I can tell you just three advantage of this: embedded server, auto configuration, dependency management, and I can simply cover this whole video in 15-20 minutes itself. But without understanding the servlets, what problem exists, what Spring MVC solves it, and what are the problem in Spring MVC itself which Spring Boot solves it. Without that, it's a partial knowledge. But I hope you like it and you will share it with your connection if you think it will help them. So thank you for that and see you in next video. Bye.